Factor x squared plus 2x minus 6 if possible. Well, we're going to check to see if it's possible. We're going to check to see if it's prime. To be prime means that it's unfactorable with integer coefficients. In other words, you can't just use regular whole positive or negative numbers to factor it, which means it's more complicated than we're ready for. So let's see. Here's the test. To find out if we have a prime polynomial which cannot be factored over the integer coefficients, we will figure out what a, b, and c is by comparing x squared plus 2x minus 6 to the standard ax squared plus bx plus c. Comparing that, we see a equals 1, b equals 2, and c is equal to a negative 6. Now we'll see if the b squared minus 4ac equals a perfect square number. If it does, then it can be factored. If it does not equal a perfect square number, it cannot be factored. Okay. So let's go ahead and do this. We figured out what a, b, and c is. Okay. So now we're ready to compare to b squared minus 4ac. Does that equal a perfect square? Well, let's see. B squared minus 4ac in this case will be equal to parenthesis squared minus 4 times parenthesis times parenthesis. The first parenthesis gets the 2 because b is equal to 2. The second parenthesis gets a 1 because a is equal to 1. And the last parenthesis gets a negative 6 because c is equal to negative 6. We simplify that. 4 plus 24 is 28. 28 is not a perfect square. 25 would have been a perfect square because it's 5 to the second power. It's 5 squared. 5 times 5. Let's see. 36 would have been a perfect square. 6 squared is 36. Let's see. 16 would have been a perfect square because 4 times 4, 4 squared is 16. But 28, no. You cannot take a number and multiply it by itself and get 28. Therefore, what does that mean? It means we can't factor this guy. It means this polynomial is prime. It cannot be factored over the integers. It's prime. And we're finished.